Hi everyone, I am Aishwarya DT. Today we are presenting our second review progress of our project, that is Women's IoT Safety Helper Band. Next I am explaining our content page. Yeah, in our PPT we are explaining the topics are problem statement and objective, system architecture, sensor data acquisition, data pre-processing, data structure and cleaning, communication protocol, data flow evaluation, and summary. Next come to the problem statement part. First we identified the core problem of our project. Today women facing increasing safety risks in public and private spaces. In panic situation, even a few seconds can be a dangerous. During emergencies, the phone may not be accessible, or battery may be low, or user may get a panic. Existing solutions are not always wearable or instantly accessible. So these challenges motivated us to design this project, that is wearable safety solution. A simple action should be even though trigger help. Since it is worn on vest, it is always accessible. No need to unlock the phone or open an app during the stress condition. Based on these problem and motivation, we defined or designed following objectives, that is sensor help automatically detecting the emergency conditions. The system should trigger alert immediately, and the device should be easy to use, reliable, and suitable for daily wear. Next slide will explained by my friend Chandana. Start.
Good afternoon, everyone. I am Chandana. I am going to explain the system architecture. Here we used the system components, the hardware components like microcontroller, like Arduino, and a panic button, GPS module, GSM module, buzzer, battery battery. Then the software components we used is a embedded C and Google Maps for location tracking. And what is the working principle of our system architecture is the user presses the panic button on the smart band. The microcontroller gets activated immediately. The GPS module retrieves the current latitude and longitude. The GSM module sends an alert SMS, emergency calls to predefined contacts. So the messages contain like an emergency alert text, Google Maps location link. The buzzer is activated to alert nearby people. So the entire process works without Bluetooth or mobile app support, and we will further implement a Bluetooth connection. And why we not introduce the Bluetooth here means Bluetooth requires a constant pairing, connection failures may occur, or smartphone must be nearby and active. So and it causes delay during emergency. GSM provide direct and reliable communication, works independently of smartphones. And what are the advantages of this? No Bluetooth dependency, works without a smartphone, faster emergency response, simple and reliable design, suitable for real-time safety application. And the application of these are women safety system, girl student, night shift employees, and many more. Thank you.
Hello everyone. I am hello.
Start.
Hello everyone. I am Nur Mujassim. So my topic is sensor data acquisition. Here, sensor data acquisition is the process of collecting real-time information from various sensors embedded in the device. So sensors used here are GPS sensors. Hello everyone. I am Nur Mujassim. So I am going to explain about sensor data acquisition. Yes, sensor data acquisition is the process of collecting real-time information from various sensors embedded in the device. So the sensors used here are captures GPS sensor. It captures the real-time location, that is latitude and longitude. Here we have used the panic button. Uh, it uh, it is the button where we can trigger the emergencies manually. Here it collects the data like location data, motion and movement patterns, audio signals, emergency alert triggers. So here next coming to the acquisition method, data is collected in real time through IoT sensors. Sensors are connected to a microcontroller or mobile app. Data is transmitted immediately for emergency action. Here this ensures instant detection and fast response during unsafe conditions. Data pre-processing, raw sensor data cannot be used directly, so pre-processing is required to improve accuracy and reliability. Here pre-processing steps are validation, noise handling and transformation. Validation ensures that sensor data is complete, accurate and within valid ranges. Noise handling is it removes unwanted signals caused by sensor disturbance, environmental noise or sudden errors. Here transformation means it converts raw sensor values into meaningful formats such as readable location, coordinates or motion patterns. Pre-processing improves decision accuracy and system performance. Thank you.
Hi everyone, I am Lakshmi. Now I am going to explain data structuring and cleaning. Data structuring to ensure proper data handling, the sensor data was structured based on its type. The FSR sensor values were stored as integers since they provided analog readings with a fixed range. The GPS data was handled as floating point values to accurately represent latitude and longitude. The button input was treated as digital data with only two possible states, high or low. This clear data structuring helped in efficient processing and reduced logical errors in the program. Data cleaning was necessary to remove unwanted or irrelevant readings. A threshold value of 100 was applied to the FSR sensor to filter out mirror or accidental pressure. Sensor data was processed only when the button was pressed, ensuring that readings were intentional and valid. Any invalid or noisy readings were ignored to improve system reliability and accuracy. Data storage. The processed data was stored in variables within the Arduino or real-time access. It was then displayed using the serial monitor for debugging and monitoring purpose. The system is also scalable and this data can be extended to load state or GSM modules for remote monitoring and emergency alerts. Thank you.
Hello everyone, my name is Koel. I am continuing with the part communication protocol. So here the protocol we used is UART, that is Universal Sata. Hello everyone, my name is Hello everyone, my name is Koel. I am continuing with the part communication protocol. Here we have used UART. The full form of UART is Universal Asynchronous Receiver Transmitter. So UART is a serial communication protocol that transmits data bit by bit between devices. It operates asynchronously, meaning it does not require a clock signal. Both device agrees on a band rate beforehand. In Arduino-based systems, UART is commonly used through TX, that is transmit, and RX, that is receive pins, and is easily accessed using the serial library. So, reason for choosing UART is it is simplicity and reliability. Means UART is straightforward to implement and widely supported by microcontrollers like Arduino. It is stable for short and medium distance communications and works well for continuous sensor data transmissions, and it is real-time monitoring. Means UART allows data to be viewed intensity on the Arduino serial monitor, which is extremely useful during testing, debugging, and demonstrations. This real-time feedback helps verify sensor readings and system behavior without additional tools. The third point is minimal hardware requirement. Only two communication lines, that is TX and RX, are required, along with a common ground. This reduces wiring complexity, low cost, and minimize chances of hardware failure, making it ideal for compact embedded system. So how the data is transmitted? So here the types of data set. The system transmit FSR, that is force sensitive resistor values to measure applied pressure of or force. GPS latitude and longitude provide precise location information. This contribution allows both physical interaction data and location tracking to be communicated simultaneously. The second point is controlled data transmission. Data is sent only when a button is pressed. With which prevents unnecessary or continuous data flow. This ensures meaningful data transmission, reduced processing load, efficient use of communication bandwidth, and scalability and future explanation. UART based communication can be easily extended by interfering with GSM modules for SMS or cellular data transmission, Wi-Fi modules, that is ESP8266 for cloud connectivity, and IoT platforms for remote monitoring and data analytics. This makes the system future ready without major design challenges. The next part will be continued by Shilpa. Thank you.
Good afternoon, everyone. I am Shilpa. Now I'm going to uh, continue about data flow and evaluation. Here it includes latency, reliability, and observation. Here the data flow directly from the sensor to the Arduino and making the system fast and simple. And the LED and buzzer respond with a very low delay because there is no network communication, and the system is reliable due to wired connection and works consistently as long as power is available, so that overall the system provides fast, accurate, and dependable emergency alert, uh, making it suitable for real time and connections safely monitoring. Next is next is summary. So here this picture shows the our whole complete work of our project, and in by this by including this I will give a shortly summary of it. This project is an IoT-based women's IoT safety band. This uses the force sensor to detect emergency situations. When force is applied, the Arduino immediately activates the LED and buzzer to give an alert, and the hardware and programming are completed successfully, and the system works correctly in simulation, and it is ready for future IoT integration. Thank you. Next slide continued by